All right, so questions? Yes.
So for the PA2,
Mm-hmm.
the initial number of states must be at least 10.
Mm-hmm.
And they need to be a valid integer.
Mm-hmm.
So it doesn't meet the requirement. We just print a message and it takes the game.
Correct, exactly. So if the user says stick, haha, that's an error, print a message, exit. If they say stick -20, if they say stick 7, errors, print a message, exit. If they say stick 12.5, that's not a valid integer, error message, exit. Stick 22, error message. Stick 20, haha. Stick 20, haha. All of those are error conditions, print a message, exit. If they say something like stick 20, play the game with 20 sticks. If they just say stick, ask them how many sticks to play with. And if they say haha, -27, 12.5, 20 space 2, 20 haha, error message and exit. If they say 15, play with 15 sticks. So there's no one simple sentence or one single C statement that captures all of this, right? It's a series of conditions. Yeah?
Can you talk about, if you have done modularization and also an example?
Yes. Thank you for reminding me. Sorry, also what?
An example of the syntax for calling a function.
Okay, yeah. All right. Any other questions on what the program should do to start off? How you specify the number of sticks? Don't throw a seg fault. That's not a valid error message. Yeah.
I don't know. Mine's more just kind of a particular how I've been struggling with. I can get it to where it recognizes any kind of issues with like decimals or small numbers or things like that.
Mm-hmm.
The very instance I'm struggling with is 20 haha, anything like that.
20 haha with no space?
Yeah.
Okay.
The way I have it set is that it recognizes and stores characters. I'm seeing that whenever from the AskKhan app.
Mm-hmm.
But whenever I have that in there and I pass it back the number, it's like, okay, cool, there's the number, I'm great. But it's like, hey, you should have noticed this extra part at the end that makes it bad.
So you're using a function to do your checking of the syntax. You're putting that in a separate function and passing back a code?
Yeah, I made it kind of just like how we did ODP, the one on Friday.
Yeah.
So I kind of followed that model, but and so I have that %D, %S, so it can see that, and
okay, good.
It captures that, but it's still like, okay, it has a number. What's the problem? It's like, well, it has this extra part, and
So there's a few things you can do. You can take that function that you're using, right, and have it pass back a sort of coded message in its return value. If it passes back a number that's bigger than or equal to 10, that's the number of sticks. There were no problems. If it finds any problem, if something got loaded that matched the %S, so there was extra stuff after that or something, pass back something that's not bigger than or equal to 10. Just make yourself a table and say, okay, if I pass back a -1, it's going to be there's some sort of problem with the input. Either it was not bigger than 10, or it wasn't a valid integer, or there were too many arguments on the command line, or it was an integer followed by something. And since we don't really care what the error was, you can just say, invalid input, goodbye. You can just make that function so if it finds any kind of error, just return like a -1 or something. And then in your program that calls it, check to see the return value. If it's -1, print an error message and exit. Otherwise, it's the number of sticks. But also, you know, it's legal to not specify anything on the command line, right? So maybe use a return value of 0 to say, you know, there were no arguments given on the command line, and use that to say, okay, how many sticks do you want? Unless you're checking argc in your main program, in which case don't worry about that.
Yeah, I was having argc and argv that passed into it.
Okay.
Based off of that, yeah, I basically was using whatever is given from the original and working with
Okay,
that side.
cool, cool.
Yeah.
And we'll talk about this a little with respect to modularization in a minute.
Okay.
Cool. All right, any other questions on high-level behavior? All right, and let me really quickly talk about ODP 451, because I posted an emergency ODP, because I actually had a request for an ODP on this, and it was a good request. So this is just an ODP to let you play with fgets. But I need internet access, so bear with me.
Yeah, it went down for us.
You think it's down?
Yeah, I can.
Oh man, that's lameness. This is the one time I don't have a backup on my local machine of this ODP. Well, anyway, ODP 451 is a function. Great. Named input. So it's void, it doesn't return anything. And it accepts a single argument, which is an array of characters. And what your function should do is remove the last character from that array. So you can assume this is a valid string, so it's a null terminated string. Might end with a new line, might not, but whatever the last character is, you want to remove that. So this is the thing we were doing yesterday in class. Just take the element at string length arg -1 and set that equal to the null terminator. So if you call this with a string that's like HELLO, it should return a string HELL. And if you call it with an argument that's HELLO with a new line at the end, it should just return a string that's HELLO null terminator. So it just chops off the last character. So write yourself a function to do this, right? And it doesn't return anything at the end. You can just say return, but you can't return a number or something because it's described as a void. But the thing it's going to work on is this argument that's passed to it, and that's the thing that you chop the last character off of. And so simplifying assumptions, you can assume that this is not empty. It's got at least one character in it, so you don't have to deal with a special case where it's empty. And you should assume that I'm lying to you. Yeah, I totally made all that up. So what you want to do is use fgets to read standard in into arg, and then remove the last character. Okay, so rewind. So your input function should call fgets, read from standard in, load the thing that was read into arg. Right, so just use arg as your first argument in fgets, and then chop off the last character of that. So when you call input, you can assume it's been given a pointer to some sort of character array in memory, and you can assume it's big enough to hold 120 characters. So for fgets, you can use 120 as your size. Does that make sense? All right, so in your main program, when you're testing this, if you call input and you type in hello, enter, it should return just hello with no new line at the end. So it's like a chop function. Okay, so write that, test it, and then link it with /temp /odp 451 main.o. I think that's what it's called. It's in the README on Canvas. And go ahead and assess it. Does that make sense? All right, let me try this once more. The funny thing is I probably got email explaining what the problem is, but I can't read it. All right, no Wi-Fi, we can live. All right, let's talk about this idea of modularization. So modularization, all I really mean is sort of breaking your code up into pieces really to make your life easier. And I'm not going to take off points on PA2 if everything is just one big monolithic function called main. But your life gets easier if you sort of break things that are logically their own functions into separate functions. It's easier to develop, it's easier to test those pieces as you write them, and then your code gets easier and easier to build the higher levels of. So what does our stick program do? What are the functions in main? Decide how many sticks. Decide the number of sticks to play with. While the game is in progress. Ask the user how many to take. Adjust the pile. Print the pile. Decide the number for the CPU to take. Adjust the pile and print the pile. And while we're in here, check for a winner every time that you adjust the pile. See if the pile is down to 0. And if it is, print out a message, I won, and just exit the program. Or something. There's different ways you can control the looping of this. So decide number of sticks to play with. Gotta look at argc. If it's bigger than 2, it's an error, print that out. If it's equal to 2, take the command line argument argv bracket 1, run it through scanf. Make sure there's nothing after an integer, make sure there's an integer, check its value, make sure it's in range. Whole bunch of stuff to do. And you can put all of that into a function, like input, or whatever we called our function the other day. Was it parse? What was the ODP called for Friday? Do you remember? We'll say it was parse. So in your main program, you might do something like this. So check for command line arguments. So rather than writing, 15 lines of code here, I'm going to say something like command line argument equals parse argc, comma, argv. Right, so I'm going to call my parse function. I'm going to pass it the command line arguments, argc, argv, the things that went into main. And let's say I've written my parse function to return -1 if there's any kind of error. Right. So if it returned -1, I'm just going to say error. If CLA is equal to 0, so this is an error. If CLA is equal to 0, no command line argument given. And so here I want to print out a message saying enter the number of sticks, and read that with an fgets and interpret it with AskScanf and so on and so forth. Maybe I'm going to put that all into another function, right? So I could say CLA equals ask user for right. I'm going to call a function called askUser for number of sticks, and that function is written to return an integer, which is either the number of sticks or -1 if there's an error. And so after this, I'll say if it returned -1, print out an error and just exit. Otherwise, I know that CLA is the number of sticks that I want to play with, and I'll go ahead and continue the code with that. But what you might want to do is actually enhance your parse function so that if argc is equal to exactly 1, meaning you ran it with no command line arguments, inside parse you do this business of, okay, print out the message, enter a number of sticks you want to play with, fgets that, AskScanf, check the value, and roll that into the return value from CLA. So CLA either returns -1 if there's an error, or the number of sticks you want to play with. And now the start of your whole program just looks like that. And maybe I'd call this, number of sticks equals, and if number of sticks equals -1, print an error and return. Otherwise, at this point, number of sticks is the number of sticks you want to play with. And now you've taken, all of this, and it's just one function call and one if statement. Okay, we want to ask the user how many sticks they want to take. Got to print out a prompt, got to do fgets, got to do AskScanf, got to see if it's a valid integer, and if it's between 1 and 3, and if it's not, you need to go back, prompt them again, do an fgets, do an AskScanf, so you need a loop inside there. Throw all of that into a function, right? Make yourself another function called here's a function called getNumberFromUser, and it returns an integer number to take, and it's going to be an integer which is either 1, 2, or 3. And this is just going to be a call like that. Now inside that function, it's going to do the printf, it's going to do the fgets, it's going to do the AskScanf, it's going to have a while loop which says if there's any problem, reprompt, re-fgets, re-scanf, recheck, and do that forever until eventually the user finally puts in either a 1 or a 2 or a 3, and then just return that as the value of this function. So to call it, I just do something like this one line, and all this other stuff happens inside. So if I do that throughout here, my main program is about 10 lines of code, right? It's a call to initialize, it's a while loop, it's a call to get the number from user. I might have an adjust and print pile, which I pass it the number of sticks to take, and it automatically subtracts that, and then it does my little loop to print out the pipes and the number in parentheses. And maybe in that function it also checks to see if there's a winner, and maybe it returns a code. If it returns 1, the game is still going. If it returns 0, the stick pile was down to 0 sticks and the game is over. And now all of this can go into, 2 function calls. So it's basically this idea of let's think of our main program as just what are the high-level steps you wanted to do. And then you break each of those into what are the steps required for this. And you can keep breaking things down into smaller and smaller pieces. And if you do this right, it almost feels like you're not actually writing any code. You're just saying, oh, I want to do this. Well, what does this do? Well, I just want to do that and that. And eventually, at some point, you actually do write code, but the code you actually write might be 2 or 3 lines. It might be an if statement, or an fgets and an scanf. Relatively small pieces that are kind of on par with the one-day programs, right? Sort of single function behaviors. And so there's sort of generally 2 methodologies that we can talk about here. There's top-down design, where you start off by writing your main program and it's just a bunch of calls to functions that don't exist yet, but that you have an idea in your mind what those functions should do. And then you start writing those functions. You say, okay, I want to write a function called parse, right? And maybe that's just a call to a bunch of other functions that don't exist yet, but you have an idea what they want to do. Process command line arguments, prompt user, something like that. And so you start at the top and you work your way down. The other approach is bottom up, right? You start by writing the smallest functions. So I'm just going to write my function that prompts the user for the number of sticks and decides if it's correct. And I'm going to write a function called parse that deals with command line arguments. And I'm going to put those together into something that I call, initialize a stick pile or something. And you build your way up. Yeah.
I've been trying to modularize the user turn,
Mm-hmm.
and I would really like to return 2 values,
Mm-hmm.
but I'm running into the problem of only being able to return 1, and I was wondering if there's a way to return 2.
So yeah, first question though, which isn't really addressing your question, but what are the 2 values you want to return?
The resultant from the scanf, and then the value that the user inputs.
Okay.
Or that could also be a total, user minus total.
Okay. So you may be able to code that some way or move more functionality into the function itself. But if you want to return values, there's a few ways to do it. So you can always do something like that. You can pass by address whatever variables you want, and inside your function, you declare those things to be pointers to integers. And then if you want to give it a value, you can do something like star v1 equals, or star v2 equals. And when you get back to your function, val2 will be equal to whatever that was, and val1 will be equal to whatever that was. So that's one way to pass back multiple values. You always get one for free, which is the function value itself. But you can do value passing through the arguments themselves. The other option is to use a structure. And if you don't know structures, this probably isn't the moment to figure them out. But a structure basically lets you make a single variable that contains, say, 5 integers and a character and a string. And that's something that you can return as a function value. And you can say, my structure equals function call, and you'll get back a big thing that has all these different values in it. And that's sort of the more proper way to do it. So, yeah.
Is there a way or a place where we need to store the functions that we're going to use to make them accessible to a program?
Are you doing everything in one file? Or are you splitting into multiple files?
Probably one file.
Okay, so if you're in one file, everything kind of works. So we'll just do some funny functions here. Okay, I don't know what these functions are supposed to do. This is going to print our hello message. Get a number from the user. And then print a pile of sticks. Please don't put this in your PA2 and ask me why it doesn't work, because this is not PA2 even though we're talking about sticks. It's totally junk code, okay? Throwaway code. Okay, so there's our really useful function 1. Okay, so this will probably look familiar. Alright, so we'll read in a line from the user and we'll scan it with a %d %s, and if scanf returns exactly 1, then we know that they entered a number and we'll just return that number. I'm going to change this. Alright, I think this will work, so we'll prompt them originally, we'll do an fgets, and then we'll try to scan it as a single integer. If it's not a single integer, we'll ask them again to enter a number, we'll do another fgets, we'll go back to the top of the loop and rescan. This should keep asking them until they type in something that's actually just one integer, and then we'll return it. And then our func3 is just going to print out a pile of sticks. So there's an example of modularization. And to use this, we do need to prototype our functions. So we prototype by basically writing down the description of the function in the first line. So func3 is returning void, it's expecting an integer. Func2 has no arguments, returns an int. Func1 has no arguments and returns a void. And when you prototype, you don't need to specify a variable name. It'll actually let you do that. But really, all you're doing is you're specifying the type of argument. So it's probably best to just say, int, for example, to say it's an integer. So if we run that, it prints out the header there and what's up, and I can say hi, 2.5, 2, haha, nothing. And then if you finally put in a number like 7, then it prints out the stick pile. So silly functions, but that's the idea of sort of breaking it up. If it's all in one file, you simply prototype in the beginning and make sure you defined the body of the function somewhere in the file, and it will compile it all together and you're good to go. If you want to split it into separate pieces, that's a different question. And we can go about that in another day. But it's usually easiest just to put it all in one file until things get really big. All right. Other questions?
It won't matter to you if it is broken up into separate files?
It won't matter to me as long as it's all over on GitLab in the same repository. Yeah, I'll just compile everything together. So eventually, in a few weeks, we'll talk about makefiles. And makefiles are something that goes along with a file, so that if you break this into different pieces, say you've got a file for func1, a file for func2, a file for func3, and a file for main, right? Then to build your executable, you need to compile all four of those and link them together. So normally just gcc star.c will give you an a.out with all of those built together. But if it gets more complex, right, it may not be clear what needs to be compiled. You may have some code that's not actually part of your final executable and so on. So there's a thing called a makefile that's basically a script that tells the system how to build an executable out of these source files. And generally when we make a program and it's split into multiple pieces, we also provide a makefile. And it's a nice standardized format, and if you have a makefile, you can just say make. And there's a program called make that'll read the makefile, look at your files, and compile exactly what needs to be compiled and link things together in just the right way. So if you download a project from the web, if you've got a camera and you want to download some software to be able to interact with it, you go online, you find someone's GitLab repo or GitHub, and you pull it down and you get a whole bunch of files. You get 300 files, and one of them is called makefile. And usually all you got to do is say make, enter, and it'll magically put everything together and give you an executable. Sometimes you have to do a config step first, but so we'll learn about makefiles in a few weeks. And in 2.22 you'll probably break things into pieces and include makefiles with them. So that's down the road. All right. I can't push that to the server because I don't think I have a connection yet. So other questions?
So OPP picked 451K tomorrow morning?
Mm-hmm. Yeah. Assuming the network comes up. Anything else? All right, so more Unix. What do I want to call this? Just for future reference. So, let's see, we did wildcards yesterday. Control C, move, copy, remove. Directories. So I'm in this directory. I can say cd to files. I can say cd to 224. If you say cd and you just put in something that doesn't begin with a slash, it's usually a relative directory. So in my current directory files, I wanted to move into a directory underneath that called 224. So if I'm in files and I say ls, I've got all these files and directories in here. And one of them is called 224. So I can cd into 224, and I can say ls, and I've got a bunch of stuff in here. So some of these are directories, they start with a D, and some of them are just plain files like returning arrays.c. So funcs is a directory, starts with a D, so I can change into that directory. And pwd shows you what your directory is that you're in right now. So dot is always an abbreviation for your current directory. Dot dot refers to your parent directory, the directory above you. So right now I'm in 224/funcs. If I cd to ... now I'm back in 224. If I cd ... again, now I'm in home nic files. If I do it again, I'm in home nic. If I do it again, I'm in home. If I do it again, I'm in slash. If I do it again, I stay in slash. You can't go above the top level directory. So the root directory is considered its own parent, I guess. If I just say cd, that changes me to my login directory. So wherever you are when you first log in, cd takes you back to that. If you need to go to another directory for a while, but you want to come back to where you are, you can actually say push directory. And let's say I want to snoop around in /bin. So I can say push directory /bin. It's like a cd /bin, but it remembers where I was before I did this. And now I can, you know, move around and do whatever I want. If I say pop directory, it takes me back to where I was when I said push directory. So it's a stack, right? If you've done 270, it's a stack. The last thing that you push is the first thing that you pop. And you can nest these. So I can push over into bin, and I can push over into EDC, and I can push over into tilde/desktop. And it's showing me my stack each time that I push. The top of the stack is desktop, the next thing is etc., the next thing is bin, and the thing at the bottom of the stack was my funcs directory. And now when I pop D, it takes me back one at a time, and it shows me what the stack looks like. And if I try to pop when there's nothing left on the stack, it tells me the directory stack is empty. That's a stack underflow. I don't know why it got dark out there. All right, so different ways to move around the directory tree. So you know about the man function, right? Man, the name of a command, gives you help on the command. At the very least, it will tell you a one-line synopsis of the command, a list of how to use it, and a description. And then it usually just goes on into more and more detail. These are all the switches you can put on the GCC command, right, to turn different things on and off. It's a really, really versatile command. I imagine somewhere there's people who understand what all of these things do, but I'm not one of them. Oh, I saw Vax. Nice. So we don't usually read these things from start to finish, because they can be a little TLDR-ish. I'm curious now. Will we hit 10,000 lines? Oh yeah. I used to know how to go to a line, but I can't remember it today. But these are useful for you know, simpler commands maybe. So if I want to know about the who, well, I can show the time of the last system boot with who-b. I can look at dead processes. That's not a very complex utility to use. So there's also man-k. Because, you know, you're trying to spell a word, someone says, look it up in the dictionary. Well, you can't look it up because you don't know how it's spelled, right? Same problem with man pages. You want to know how to compile a C program, well, look it up in the man page. Well, if you don't know the name of the command, you can't look it up. So you can say man-k, and it will basically look at that one-sentence description of each command for whatever keyword you put in here. So if I say man-k compile, it'll show me all the man pages that mention compile, uppercase or lowercase, anywhere in the description. And it's a much shorter list, so there's the C compiler, C89, C99, there's the C++, there's GNU C, and so on and so forth. So keyword option is useful. Alright, you know about cowsay. You know about SL, right? So if you mistype LS and you do SL, you get the steam locomotive. And apparently if you do uppercase LS, I didn't realize that, but someone mentioned it. And then LolCat, which takes a file and prints it out in a rainbow. So that's useful. Fortune, which gives you a fortune. Oh, there's no fortune? I'm on my own machine. There is a fortune on the Linux server, but I don't have it on mine. I don't have internet access. Anyway, run fortune and it gives you a fortune. Maybe not safe for work, but I didn't write it. There's also AskKhan. So Khan was a student in the 200 series CS sequence last year, and he made his own version of fortune based on lessons he had learned from the class. So they're like somewhat related to subject matter at hand. We looked at top, right? We've talked about PS a little bit. This will lead into a bigger talk about processes, but PS is a quick way to sort of see processes that you have running. And if you want to see everything on the system, ps-elf does that. And we don't really need to worry about this too much for now, but we'll play with PS more in a few weeks. Octal dump and XXD. So I've got this file called Go. If I try to look at it, it's gibberish, right? It's got the magic elf in character position too. But it's 9,300 characters. It's not human readable. This is the executable program that the CPU kind of grooves on, and the operating system runs as executable code. So if you want to see what the contents of the file Go is, a really useful command is xxd. If you say xxd go, it shows it to you in a more controlled way. So it shows you positions in the file, and these are hex numbers, so starting at position 0. And then it shows you in groups of 4 hex characters the ASCII code of everything in the file. I mean, it's not necessarily an ASCII code, but the hex equivalent of the binary values that are stored in the file. So it starts off with a 7F, which is not printable, so it displays a dot over here. But then it's a hex 45, which is the ASCII code for E, so it displays an E. 4C is an L, 4.6 is an F. So we see printable values for anything that falls within the printable range of ASCII codes, and periods otherwise. So 0 is not printable, 2 is not printable, and so on. But it's one way to get a view of your file, and if there's stuff in there that's human readable, you'll see it over here on the right. But the actual value of the binary code is presented in hex. And this may or may not be useful to you. But let's look at let's look at some examples. So if I cat file 2, it says hello in a new line. If I cat file 3, it does other stuff. That's xxd file 2. So it's H, E, L, L, those are 6 C's, O is 6F, and then 0A, so what is 0A in decimal? Hex digit A translates to what? 10, yeah. So 0A, that's ASCII character 10, basically, if we try to look at it as a character. 10th letter of the alphabet is J, so it's basically a control J. Well, for no particular reason, control J is a new line. Okay, that's kind of an old school notion. But when you have a new line at the end of your file in Unix, it's character 10. That's what that 0A is. And there's two of them because there's an extra new line at the end. If I changed file 2 to just be a single line, right, one line, and I XXD that, there's only a single 0A at the end. That's the one new line. And if you count up the number of characters, 4865, 6060, 6F, 0A, that's 6 characters. Well, that's what VI is telling me when it says one line, 6 characters. So if you really, really want to know what's going on inside a file, XXD is a really good go-to. Okay, it lets you see byte for byte what's actually stored in there. It doesn't matter if it's a printable file, if it's an executable file, if it's a JPEG, any file on the system that you have read access to, you can take it apart with this. And we'll talk about pipes probably tomorrow or next week. But if you say xxd go or any command and you put in this pipe and then say more, it runs the command, but it puts the output through more, so I can look at it one page at a time. And I can space forward by going space. And I can go forward a line at a time, and I can search for things, and so on and so forth. So throw XXD in your bag of tricks and see if you use it. Alright, so we'll continue from here tomorrow. So I'm in at 7 tomorrow for office hours, 7 to 9:30. If you've got PA2 questions or ODP questions, catch me then. Okay, we got internet.